How far is the school from their house? We got Sophia and Daniel. They jogged to school. They're brother and sister, and so we're assuming they leave from the same house. Here's my house. Here's the school. S-K-O-O-L. Capital L at the end. Okay, we don't know this distance. We don't know how long it takes. We'll call that the letter D. And then something we also don't know. We also don't know time. We don't know how long it takes Sophia or Daniel to jog to school either. It'll be different for each of them because they're running at different rates. So let's start with this. The distance you travel is equal to the rate times the time. Right? If you're traveling at 60 miles per hour for 2 hours, then you travel 120 miles because you just multiply the two. So for Sophia travels this distance equal to her rate times an unknown number of hours that it takes Sophia to get there. Daniel's going to travel the same distance. If we say that the time is the same, like if we want to stop time when Sophia gets there, then Daniel is 6 times t, but Daniel still has to travel an extra 1/4 of a mile. Actually, let me think about how we can work that 1/4 of a mile away. Yeah, here, so Daniel hasn't quite made it. We got to subtract the distance to the school by 1/4. Okay, so this is the trickiest part of the problem. After this, when we start looking at it as a system of equations, it'll be easier. This is Sophia's distance is 10 miles an hour times the number of hours Sophia travels. Daniel, same thing, distance equals rate times time. But if t represents the time Sophia is at school, if t represents the hour that Sophia makes it, then at t time, Daniel still has a 1/4 of a mile to go. So we got to take that, whatever that total distance is, 6 miles, subtracted by 1/4 of an hour. 1/4 of a mile, because that's how much more Daniel still has to go. There's other ways to set up this equation. I'm trying to think of another one that might make more sense, because sometimes one explanation works with some people, doesn't work with the others, and that's totally understandable. But if you take these two equations, and you'll just have to adjust your numbers a little bit, right? You can solve them as a system. Instead of D, I'm going to put 10t in the bottom equation. So this bottom equation becomes 10t minus 1/4 equals 6t. So that's an equation I can solve for t. So I'm going to subtract 6t from both sides. Trying to get t by itself, so I'm going to add 1/4 to both sides to get rid of it. And then to finish getting t by itself, I'm going to multiply both sides by 1/4. So that's 1/16. So it's not too far from school, 0.0625 hours to reach school. And so the distance would just be plugging in time into Sophia's equation. Okay, or you could plug it in Daniel's to get the same thing. Distance equals 10 times 1/16. So the distance to school is 10/16, which simplifies to be 5/8 miles, 5/8 of a mile.